After that, I landed a job outside of my degree, really in the construction industry. So doing mostly civil structures like bridges, structures, did a bit of pavements in the construction space. Did that for about 4 years, and then realised that I sort of wanted to get into more of that design space, because back at uni, I used to love doing calculations, like long nights, doing long handwritten stuff. Used to love that. So I wanted to get into that field. I enjoy that stuff a lot, but I've got some soft skills as well that I love as well. So I like talking to people. So at the moment, I'm in more of a managerial role in the project that I'm working on at the moment. And I do enjoy that too. So it's hard for me to say, and because I've had that construction experience as well, that's mostly all people skills. So it's hard for me to say, I like one better than the other, because I enjoy it a lot. Everything's different, all the properties of the fluid's different, all the rheology of every mine is different, every recipe for every process is different, so everything changes. So you can set up tools, because I've seen it, you can set up tools for sizing a pump, for example, that incorporates macros, that do all this amazing stuff, which will expedite setting up spending a week setting up a new calculation to set up a new pipeline or size a new pump and look at pump curves and all that. Like you can do all that using macros. I've seen some pretty amazing stuff that I could never put together. I'm pretty happy with what I'm doing. It's pretty fulfilling. Every job has its ups and downs. I've worked in a few different industries and sectors, and they all have good days and bad days. Some tasks are monotonous and boring sometimes, and some tasks are awesome. So it's like everything. Really. So I'm not really thought about, I want to go do this or go do that at the moment. But we'll see what the future holds.
Hey everyone, thank you for coming back to another episode of the Noor Podcast. Today we have Josh as our guest. Before we get started, I just wanted to say a huge thanks to everyone that watched the last episode. And if you enjoyed it, please consider subscribing and comment what you think about everything, and give us a like as well. It really, really helps us. But without further ado, this is Josh. Maybe you could start us off by telling us a little bit about what you did at uni, maybe, and what your experience has been until now.
Sure. Yeah. So at uni, I studied mechanical engineering. I think you did the same. You might have done the same. It took me 5 years to do my degree. I did part time, because as I was saying before, I was working night shift at the airport. So and did a little bit of travel in between. So saw a bit of Europe, got a bit of that under my belt. Landed a job in control systems for a control system company when I did my internship. So did my final year working in the engineering field while doing my honours, and then after that I landed a job outside of my degree, really in the construction industry. So doing mostly civil structures like bridges, structures, did a bit of pavements in the construction space. Did that for about 4 years, and then realised that I sort of wanted to get into more of that design space, because back at uni, I used to love doing calculations, like long nights, doing long handwritten stuff. Used to love that. So I wanted to get into that field. Found it very hard to transition. I was actually talking about this earlier today. Found it very hard to get out of construction and get back into consulting, especially being in a field in civil structural where you weren't practicing as a mechanical engineer, and then you want to take that side step to go into the mechanical discipline. It's like nobody really wants to take you on, especially because it's so different. Like you're in project delivery, in execution, sort of in that space where you want to go into the design stuff. Nobody really wants to know you. So I had to sort of apply for a graduate program, sort of start again at square one after 4 years of working.
That would have been
just to get noticed. I wasn't getting any love. Like nobody wanted to pick up my CV and give me a call and say, even have a conversation or entertain the idea of an interview.
What year was this in terms, because I know the market, the economy is very different now. It's so easy for engineers to get a job, but
I made the jump, I reckon, in 2020.
Yeah, okay.
Yeah.
Before COVID.
Before COVID.
Yeah,
no,
okay.
sorry.
Just before.
2019.
Yeah, okay.
Before
Yeah, I think it was a bit tougher because I remember because that's about the time I started going into engineering, and I remember conversations that people were having with me at the time. It's like, don't do it, you'll never get a job. Because I think it was quite tough then. But
sorry, no, it was after COVID.
It was after COVID.
Yeah.
Yeah, okay.
So everybody was working remote. Because I remember when I started, there was a few people, still a bit hey going about going back to the office and all that. So. But I landed an opportunity to do a graduate program, ended up talking my way out of it, so I was lucky enough to not have to do a 2-year program again. And then was there for about 2 years, sort of felt like I outgrew my role and then moved on to another company, and I was reading textbooks and I was understanding all the theory and everything and making sure that I was having conversations with lecturers and tutors and making sure I was understanding all the concepts. So reading cover to cover textbooks and really making sure I understood it. So it was a lot of that research type stuff, reading papers, understanding theories, understanding equations, really figuring out how that stuff worked. And then what I most enjoyed was doing calculations and solving problems from start to finish.
Yeah.
A lot of it was calculus and stuff. So when you're writing out equations on paper, you're doing 5-6 pages, and you're quite proud of that stuff.
Yeah. And did you get to carry that into your roles as well?
Well, I don't do any calculus.
No.
And any paper that I open these days, it's been too long. I've forgotten calculus, but you can still, your algebra, you can still apply your theories and stuff, but I cannot derive an equation to save my life these days. So
that's so interesting. A lot of engineers that I talk to in industry, it seems to me that, and from I just graduated last year, so I'm just pretty much fresh. I've only been in the industry for a year. What I'm being pushed towards is either two streams. I can see as an engineer, it's either you go as the SME, like subject matter expert, technical side, or you go into management. And it's pretty clear that you probably prefer the technical side. Would that be accurate? Or?
Yeah, I mean, I love technical stuff, and I can sit down and do a spreadsheet, and I'll do a spreadsheet, for example, and I'll come up with this calculation, and it'll look awesome, and I'll spend all night on it, and it'll be, before I know it, it's midnight, and you don't even know, all this time's passed, and you're super proud of what you produce, and I enjoy that stuff a lot, but I've got some soft skills as well that I love as well. So I like talking to people. So at the moment, I'm in more of a managerial role in the project that I'm working on at the moment, and I do enjoy that too. So it's hard for me to say, and because I've had that construction experience as well, that's mostly all people skills. So it's hard for me to say I like one better than the other, because I enjoy it a lot. I enjoy it all.
So you're doing a managerial role right now in terms of you're managing people?
Yeah.
Yeah, and you still get to do technical work as well, because that's pretty uncommon, honestly. A lot of times, managers are kind of just take care of people, don't touch the technical
Look,
side.
in consulting, you could find yourself in a position where you manage. It depends on how far up, sort of, in terms of experience you get. If you're a senior, you could be managing a lot of people underneath you, and you do this, you do that, doing a lot of delegating, a lot of reporting, looking at costs, looking at schedule, that type of stuff, whilst also doing design of your own. But currently we've got a team overseas that's doing our design at the moment, so they're experts.
Yeah.
They don't need my help. They do in terms of managing client and their procedures and stuff, because I've been doing that for 4 years now, so I know that inside out. But there is opportunity. In reality, you can do both. Yeah.
Yeah, well, I mean, we were able to just speak previously just before we started recording, but from what you were telling me, obviously you're in the mining industry, and obviously Nemad and I, which is the other co-host, and Mark, we're in defense, and hearing you speak in mining compared to defense, it's very interesting to me, because defense and space kind of go together, and I think a lot of times when you hear engineers from these industries talking about the work that they're doing, it sounds very, in the future, very theoretical, and it's more about ideas than practically of things that are happening. But it's interesting because at the end of the day, the backbone is not defense, because defense is the what if. We're preparing for the what ifs, but mining is we're preparing for the now.
What's happening right now?
And
for sure.
The world would collapse without it. Like obviously it's such an interesting industry to talk about, and maybe you could. Were you prepared? I mean, through uni, I didn't get much exposure to defense at all, but do you think uni prepared you well for the industries that you were going on into?
Absolutely not. I didn't even know I wanted to get into mining until I got into it. When I was sort of decided that construction industry is not really for me, and I was very lost. I was like, what am I going to do? I wanted to get into some sort of. I think that I wanted to get into like the renewable space and that sustainability type
polar
stuff.
Opposite.
Yeah, polar opposite really. And I was like, I want to have that, push the needle on changing the world a little bit. But I landed a role in mining, and I found it super interesting because like heavy industry stuff's really cool, and it's like you said before, like one of the things that I liked at uni was fluid mechanics. That was a topic that we did that was like that was like one of my strengths. I really enjoyed the theory of all that, and that's essentially like what I do day to day on a heavy industry basis. And like every day has this new challenge. A lot of fluids in the mining processing sort of space isn't the same. It's not copy and paste. It's all unique. You got to do your own research, figure out rheology on how, like fluid properties and behaviour and stuff. So that's very unique, I think, to processing. You won't find that in a lot of other industries. So I fell in love with it because I know there's always a new challenge around the corner that's going to challenge me technically. There's always something to learn, and there's always it's like I said before. There's nothing's copy and paste, so it's always new. Every project's always new. Every project's always different. So,
yeah, awesome. We have a lot of listeners, I'm sure, that in universities are starting off, but and I think one question that I've talked to software engineers before, and who like, I want to work at Boeing, I want to start off here, and then the first question they go is, what languages do I need to learn to do that? Because they're like thinking practically, it's like, what do I need to do to prepare? And obviously in the world we are in now, everything's run by software. So do you think you could answer, if there was a potential engineer that's really keen to go into the mining industry and kind of the work that you do as an engineer, and I'm curious as well, what kind of software do you deal with?
Excel.
Is it really?
Yeah, a lot of Excel. Like even my boss was like, you need to learn how to do macros. I'm like, no, I'm too old for that. Like I don't know how to do that.
Yeah.
I used to know, like I did programming in school and first year, second year uni and stuff. I cannot program anymore. But like if you know like you could set up tools. Like that's the thing, like I said before, like a lot of the fundamentals are the same, but every project has its own unique challenges. Everything's different. All the properties of the fluid's different. All the rheology of every mine is different. Every recipe for every process is different. So everything changes. So you can set up tools, because I've seen it. You can set up tools for sizing a pump, for example, that incorporates macros that do all this amazing stuff, which will like expedite setting up spending a week setting up a new calculation to set up a new pipeline or size a new pump and look at pump curves and all that. Like you can do all that using macros. I've seen some pretty amazing stuff that I could never put together.
Were you taught any of that at uni?
sizing a pump.
No. Using Excel like to that level.
No.
Which is ironic.
I think they need to do like a 4-year course on macros, man. Like the Excel is so powerful.
Excel is so powerful because it's like custom software essentially. You can just, as long as you know the theory and you know what you're doing, you can kind of do it yourself.
Yeah.
So how did you end up in engineering from a school? So what was your story back then?
Yeah, funny one. I think I finished school and then we were looking at my ATAR, sat down with mum and she was like, oh, what do you want to do? And I was like, I have no idea. She's like, oh, I think my first option was like marine biology.
Mm-hmm.
And then second was like mechanical engineering, and I can't even remember what the rest were. I think I got into like both and I was like, oh, I'll just do mechanical engineering, but I had zero clue what it actually was. Do you reckon you did?
Not really, but
I just knew it was like a lot to do with physics and a lot to do with maths, and both of those were like one of my strengths in schools.
I was passionate about AI, but I've never and gaming, but I've never studied any of them. So it's more like a self-learning.
Yeah.
So I did so many other things to like get my skills together to get to do what I want to do, and that's interesting to what you just mentioned about the software side of it. But other than that, what keeps you awake at night?
The project at hand, usually. Like, I usually think it was when I first got into consulting. It was funny. When I first got into consulting, one of my buddies, he was just finished his grad program, and he was like, oh, he did a lot of modelling.
Yeah.
And he said to me, oh, just let me know when you start dreaming about pipes. And then I'd be walking around like car parks underground, like looking at pipes, and then start dreaming about pipes and gaskets and bolt fittings and all that. And I was like, yeah, it's happened. So that keeps me up at night.
Wow, fair enough.
But it used to be deadlines. So I don't know how, but I always find myself on quite large projects. And it's always deadlines. You're always stressing about deadlines.
You just mentioned that you have a team overseas and you sort of send stuff to overseas people, and I want to touch base on that and saying we do a lot of engineering work outsourced in Australia, and I think for a long run it's going to bite us somehow. Do you think that society at the moment really values what you're doing the way they should?
How do you mean? Like in terms of?
It's an open question.
So I don't think there's a lot of people out there that actually know there's consultants or there's miners out there that actually do what they do on a day-to-day basis. Like I feel like the engineering industry, and it's not just mining. It could be like the food and beverage industry, as well as probably another good example. They don't know how much effort and how much thought actually goes into a lot of projects that happen and what we actually do on a day-to-day basis. Because like I said before, like coming into engineering from straight out of high school, I had no idea what it was. I had no idea where my place would end up, like where I'd end up in society. Like if you think about food and beverage industry, I think is probably the closest thing we have to manufacturing in South Australia specifically. Where you've got, let's put Hayes, for example. They have a production line, and if I had to compare that to Holden, I don't know if you guys have ever saw the Holden factory.
No, not in person.
So it's pretty wild. They've got robotic arms coming around everywhere, like welding. They've got cars on hoists, moving, spinning, all that type of stuff. So it's all robotic, and there's just people standing on the line, just making sure things going in place. But like that is precision engineering. You the amount of like thought, power, time, money that went into an engineer making sure that all those robotic arms are designed, programmed properly, making sure all the welds are all in the right place, the rivets are all in the right place. Like, as an engineer coming out of uni, like, would I know if I wanted to get into manufacturing and be an engineer? Like, I would have to, like, you wouldn't associate that with engineering, would you? You'd think about, designing the car, designing the door. We don't necessarily do that.
So what you're mentioning potentially is like you believe, correct me if I'm wrong, so you believe that people are, losing the process of how we do things.
I think not losing the process, but understanding the process. So
losing the understanding of the process. I meant, yeah.
Probably not losing it, but probably never understood. Never understood it to begin with.
Yeah.
But do they need to?
Well, I mean, we don't really have much manufacturing here anymore, but we do need, because if you want to get more kids going into STEM, they need to know what they're getting into. Like we talk about manufacturing, and like I think we should be looking at getting manufacturing back to Australia. But like, what does that actually entail? You're actually building, designing, and constructing a manufacturing line. It's not so much about the product. It's more about putting something together that's going to make the product.
Yeah.
Yeah,
absolutely. And with the industry we have now and the technology that's going into Industry 4.0, it looks like manufacturing is going into a space where it's even more automated, where like you don't even need people. And it's exciting to think about the engineering that goes behind that and the design that has to go behind that. Look, I think it's coming. I think it'll start small scale in Australia. It'll grow like larger eventually. I work at Boeing, and we are currently developing the MQ-28 Ghostbat, which is the autonomous drone, and that's going to be manufactured out of Australia in Melbourne at the Boeing Aerostructures Australia site. And it's one of the biggest manufacturing projects that are coming back to Australia. So
awesome.
There's little bits and pieces of things that are currently starting to reopen, and traditionally I think, and similar with mining as well, I think, is that the reason manufacturing had to leave Australia is because the labour costs got too high. But if you remove the people out of it, as cruel as it seems, you can bring it back. Like, the reason we can bring manufacturing back is that, okay, I can do this with less people, and machines don't have the highest salary as people do.
Yeah.
So it's a lot more affordable, and I can do it. And I heard similar things with mining, where it's like, yes, we're mining a lot right now in Australia, but I have to fact check myself here, but I've definitely heard that Australia has a very large amount of crude oil, especially in the centre of Australia underneath, but it's way too expensive to dig it out because the amount of labour costs it would take, we wouldn't make any profit. And it's because labour in Australia is close to, if not the most expensive labour in the entire world, that they charge. Because I think the economy in Australia has developed so much that we, I want to say we're overpaying laborers. And I always say this example.
Sorry to disrupt you. Knowing you, I mean, just for the audience, I want to clarify that when you say people, we still need people, but we need high skilled engineers.
Correct. Yes, absolutely.
And we are still love humans. We want as the economy go, flourish and all that. But I'm just trying to add to your comments on that for the audience is that we, by the way that the society is going, and we have an aging population, and we have a shortage of people, specifically high skilled people. So to be able to run the society, we need higher skilled
people. Yeah. Because the example I always like to give is that, like, oftentimes you'll see in Australia that if you go to a construction site, the person holding the stop start sign, the stop and slow down sign on the road is getting paid more per year than the civil engineer who's designing it. The graduate civil engineer, and it's kind of, and yes, they're working overtime, and yes, they're working in the sun.
Do not believe that you brought us up.
Look,
what you got against the lollipop?
No. What I'm saying is that, like, you go over to America, for example, and where skilled labor is a lot more hard, like there's a lot more value added to that, and it produces a society that encourages innovation and growth. And I don't know. Sometimes I see Australia as a bit stuck because of that system that we have. Look, it helps a lot of people earn a lot of money, you know, but is it really like growing us as a country? Is it producing? Are we producing a lot? Is there a lot of output?
Look, I mean, considering, I don't want to politicize these questions because all sides of the politics at the moment believe that, you know, we need to bring back in you know, engineering, we need to upskill people, all of that. But having said all that from all sides of the politics, there is still a lot of work need to be done. From your perspective, with your experience, what do you suggest? How do you think that the government, the people, parents can actually promote this? And if you were talking to your 15 years old or 16 years old when you were back in the school, so how do you re-narrate their story?
In terms of what bringing like manufacturing specifically, or how?
Well,
how do you tell that story again? So
we need to look at getting STEM into high school, I think, and getting kids to understand a little bit more about the day-to-days on what it's like to be an engineer, because it is fun. Like, I mean, when I was on site and I was in construction, like playing with 300, 400 ton cranes, like putting up bridges, that stuff's cool. Like that stuff was fun. In design, I'm designing 4 kilometre, 5 kilometre long pipelines, like that stuff's fun, you know. But as a kid, like you've got no idea what it takes, what's involved in putting that together, do you? Especially coming out of high school. So I think we need to, awareness is probably the word that I'm looking for. We need to make people aware, like, of what it's like to be an engineer.
Yeah, that makes a lot of sense, because traditionally, obviously, the job, like traditionally isn't way back in the day, the job that you would go into was usually your father's role as a guy. And that's generally because, you know, as he raised you, he would also teach you. And it's, again, what you have the most exposure to. But obviously, we live in a different society now, but I think somebody a couple episodes ago was saying this, but when you look at like doctors or lawyers, these are people and occupations that even children have, like they see, whether it's people they know or whether it's a TV show, they have exposure to those roles, they see what people do, and so they're like, oh, I see myself in your shoes.
Yeah, they gravitate towards that.
Exactly. But when was the last time you saw a TV show about engineering?
Yeah, never.
You know what I mean? Or even when you were in school, did you have an engineers club?
No.
I didn't either.
I had zero idea. I actually got into, it's safe to say I got into engineering by accident.
Yeah, right. Right, and look how successful you've become, like, in...
Oh, thank you.
In your own role, but also, like, when I say successful, not from a career point of view, but you've found success in finding fulfillment in your life of what you do.
I mean, I'd like to say I'm unique enough to have a good exposure across a couple of different industries, a couple of different disciplines. So I would say I'm pretty well rounded. So I've seen a lot. Like I've got a good understanding of the industry, especially like across the country as well, and what sort of engineering has to offer in Australia to people.
So what were the industries that you worked in again?
Construction, consulting, so design. Control systems in terms of discipline, civil and structural discipline, and mechanical discipline.
I see, okay. Wait, maybe you could take some time, and when I initially met you and talked to you, one of the things that you told me was that you wish you had a podcast like this, or somewhere where you can hear and listen to real life engineers talking about what it's like to work. So seeing as these are the industries that you have worked in, maybe you could tell the audience, and pretending that this is, you know, uni students, something about those industries that, you know, you wouldn't have learned in uni or without having to actually talk to someone about just what the day-to-day looks like and how it was working in those industries.
Yeah, okay. So I'll start with construction. So the day-to-day for a construction. So actually I should start with consultancy, because that's sort of the first stage of the process, or one of the first stages of the process. But
what do you mean by that when you say first stage of the process?
For a project to get off the ground, it's got to go through Parliament. Usually, it depends on who we're talking. So if we're talking I'm using an example of like a bridge going up or something to do on something that's state or federally funded. So it goes through Parliament. Then there's a whole heap of people that will do a concept study. So they will get funding approved to do a feasibility study. And then if that gets approved, then they'll engage a consultant to do a design. The consultant will do the design for a bridge, so they'll look at things like, okay, what's going to be driving over this bridge? It's going to be trucks, cars. They're going to look at traffic modelling, so someone's going to model the traffic. So, okay, how many cars a day? You know, where are people living in the area? How many cars a day go? Because that's a course at uni that you do.
Oh, really?
Yeah.
Traffic engineering.
Oh, yeah,
it's a course.
Part of the civil engineering.
Yeah. So they'll get on their computers, they'll do some modelling, and they'll go, okay, where's the demographic in this area sort of going? How many cars a day? They'll categorise the cars in terms of like size, weight. So they'll figure out like, you know, cyclic loading on the bridge, like life expectancy of the bridge.
And this is all what a consultant engineer would do.
Yeah, this is all the stuff that consultants do in the bridge space. So they'll design a bridge to sort of withstand that with it to a design life of say 100 years. I think that's pretty much the standard these days. So they'll develop a design, they'll pump out all these drawings, they'll give it to the government, who will then go employ a contractor to go build the bridge. So in my experience as someone that was building the bridge, you would get the drawings, you'd figure out how to build it. So you've got the final product on paper. All right, how am I going to put it together? So it's like Lego. It's like getting a box of Lego without the instructions. So you got to go figure it out how to do it.
Sounds fun.
And yeah, it is fun. You've got a bucket of money to go do it. You employ a workforce to go build it, and then you make sure that it goes up on time, within budget, safely, and to plan. So you've got to, like, one of the funnest parts that I thought was actually putting together a plan of a bridge. So it's like, okay, this goes down first, and then we'll do that, and then we'll put up some scaffolding here so you guys can, you know, tie some steel, and then pour some concrete, and then we'll wait a week for that to dry, and then etc. So you in the construction industry, that's essentially your job, is just to manage all that. Like, you got to make sure you buy all the tools, all the like little bits and pieces that help it go together. So
that sounds great. Obviously, it sounds like you're saying that you obviously work with a lot of contractors and tradies as well.
I mean, it varies. It's not every job's the same, but
obviously at uni you don't get taught any of that.
You don't get told any of that.
What's it like, you know, doing contractor management and working with technicians and tradies essentially, and like
some of them can be a little bit rough around here.
Do you have
It's
advice
fun.
for
It's
right,
fun.
that's going into that?
Like you do. You just got to earn your stripes, really. I mean, at first it's like, I remember when I first rocked up to site and my foreman was like, "Oh, everybody meet your new boss," and everyone's like, "Who's this 21-year-old?"
Yeah.
And then I mean, I got a lot of stick, but when push came to shove, I mean, I remember one day we had this operation. We were putting up some bridge beams, concrete bridge beams. It was 70 ton each, so we had 2 cranes on either side. It was like a $10,000 a day operation. It took us 3 days to put up, plus 2 days either side to set the cranes up. So it cost a lot of money. And there were guys in the industry that'd been in the industry for like 20 years, 30 years. But we're putting these beams into place, and I'm up there with the guys, and they were like, "Oh, you happy with that?" when they place it, and I was like, "Nah, it's not quite there." Like we're talking 10 millimeters of tolerance here, and they were just like, "All right, we'll move it," and I was like 23 at the time.
Wow.
And yeah, it was pretty like gobsmacked. Like,
sounds like you needed a lot of confidence in yourself as well in that point, like, and trust that you know what you're doing. And you got used to it though.
You get used to it. It wasn't easy at first, but it took a bit to actually settle in and, you know, earn your stripes and stuff. But then and after that, like I was on a big project that I was like, okay, I want to finish this so I can put this on my resume and say I've done it. And then, I need to get back into mechanical engineering. That's what my degree was.
Did you get that feeling of when you turn up to the site, the more qualified you are, the more bullied you get? on construction sites.
No, not really. How do you mean?
Like, I mean, if you're, for instance, do you have a master's degree and you turn up on the site, you get more bullied by the tradies than if you have a degree.
I feel like if you've got a master's degree and you rock up on a construction site, it just gets forgotten about. Like there's probably not much point in having a master's degree on a construction site.
Fair enough.
So yeah.
You know, it's part of the personal experience, but just on that side, you know, we do have a influence of AI, and we know we have been discussing about AI before this. I know AI, we know that AI, and this has been a topic of ours for the last few months, I believe, that, you know, AI has great influence and disruption probably in medical industry and in the, for instance, law and all the other, you know, industries. What do you think? I mean, this is why I'm trying to ask you the question, because a lot of audience probably don't know what's going to happen with AI in engineering or in construction. What do you think of the future of engineering going to look like with AI? I know you mentioned something about ChatGPT before starting it. Do you think engineering going to be disrupted a lot, or what's your vision?
I think it will. And I don't know if it's going to be for the better or the worse. Like I use it occasionally when I have a problem, but I don't use it I refuse to use it to get straight to the answer. I use it to, like I was saying before, expedite a lot of research that I usually would have done, and just say, and I ask ChatGPT, for example, where can I find this, and then get it to point me into that direction, so then I can read up on it myself. But I feel like, and like I was saying before, it probably will come with a lot of discipline. Kids coming through uni now, it's easy for them to just turn to ChatGPT or AI for answers, especially when it comes to assignments and quizzes and things that you're actually tested from when you're at home. And the biggest part of that, like my biggest takeaway from university was, like I was saying before, I've forgotten a lot of calculus and how to do a lot of equations. Like you know, you can duck and weave it in the industry. You don't really need it, but you need to understand
Context.
Yeah. A lot of kids, like my biggest takeaway from uni is mostly the problem solving skills that I developed. So I feel my biggest fear is a lot of people coming through uni that have AI in their pocket will not be able to develop those problem solving skills that, you know, we all had to develop to get through the system. So
yeah, I was listening to a podcast recently about talking specifically about this, and it was this philosopher, and he was saying that a lot of people compare the AI revolution to the industrial revolution when the printing press and radio was developed, and he finds that very worrying, because the big difference between these two revolutions is that the printing press and the radio helped to empower people, because it made it easier for an individual to express their opinion and to express their opinion and their skills and show it to the world, right? But ultimately, there has to be a human behind that. It amplifies the individual's, you know, intellect, essentially, and expression. But the danger with AI is now you have the technology that can think and make decisions for itself.
Yeah, it takes all that away from them.
So in some ways, it actually takes power away from humans compared to the Industrial Revolution. And so you're right. And if you haven't, it's like, you know what a great example is? It's like people that go into the workforce now, like me, for example. I started after COVID. I could not imagine going to work 5 days a week.
Into work.
Yeah. That's crazy to me. Whereas just like for you, for example, you were there before COVID.
Yeah.
You remembered 5 days a week, but that's a false reality to me. Like, it doesn't make any sense. And people, like you said, graduating out after the AI revolution, like we're right now, it's going to be a completely different ballgame. The set of skills they're going to have is very different from the set of skills that engineers before AI had. Yeah.
Yeah, and the problem The problem will be, especially in the next couple of years, will be a lot of these kids will be using it, but the industry still hasn't figured out a way to, especially in consulting, like they still haven't figured out a way to integrate that into the day-to-day properly yet.
You would think consulting would be the first one to get done.
It's not widely, like we do use it. It's okay to use, but it's not really like. It's hard to say. It's not really encouraged. I mean, it is talked about, but it's not. It's mostly around like, okay, don't disclose client information, and that's probably as far as the conversation's gone, which I think is totally sensible. But we haven't figured out. No one sat down and gone, okay, how do we integrate this into our day to day? Like I feel like there hasn't been any forward thinking in that space yet.
Do you think that?
I think that the next generation of graduates over the next 4 or 5 years will be way ahead of where industry is, and then they'll come into industry and they'll go, oh, yeah, you know, it hasn't caught up, and they're going to be, they might find it difficult to integrate into industry at the beginning.
Do you think that consultancy would be, okay, out of all the engineering fields there are that AI could potentially do the job of, do you think consultancy would be the one that probably is the most attainable for an AI to replicate? Because I only ask because, for example, mining or construction, you're dealing with a physical thing. You know, you have to be there on site, and physical hardware or like having to physically look at something and assess it is going to be very difficult for an AI.
Yeah, but it's certainly from
the information, right?
Certainly from a design space, it would be the first area for AI to take over. But like, how long is it going to be until we can fully 100% trust the design that AI puts out without it being overlooked and checked by a human? You know, and then it might get to the point one day where, you know, humans are completely redundant in the design space, and then, you know, and then something goes wrong, and then all of a sudden, you know, 20 years go by and we've just been doing the same thing, and then like doing designs from AI, and then we've lost all those skills from humans, and then how do you go back? You
gotta retrain.
Yeah,
it's scary.
I'm sure you have seen this picture, the funny picture that they have this building covered with it's a new building under construction, and they have a cover around the building and the banner says, ask ChatGPT to build it.
Yeah.
Really?
So you know, I mean, coming back to your point that you were mentioning, when it comes to the interaction between the physical world, physical assets that you are building or doing all that, as you mentioned, I believe that there's going to be a huge disruption, and you point out a very interesting point that, you know, the new generation of people coming into the workforce, because of these tools, are just way smarter, or probably as smart compared to previous generations, or at least they look like, you know, more, you know, smarter. And do you think that especially in the consultancy world, that they are ready to actually absorb this, or do you think there's going to be more startups coming up, because the younger generation coming in and saying, I don't like the way you're doing this, I'm going to go and do it myself?
I think there'll be an adjustment period for sure, because it's still so new.
Yeah.
Like, you know, when ChatGPT came out, like a year ago? In that sense, so it's still so new, and I think the industry might be playing catch up with the younger generation for a bit. So you probably, you know, I think you will find more startups.
Yeah.
For sure, because, you know, I don't think it'll be uncommon for uni students to come out of uni, sit in a job for 6 months and go, nah, it's not for me.
Well, I can do it better.
I can do it better. Probably not so much.
No.
But, I mean, it's hard to build a client list. That's the thing. Like, you know, everybody would love to work for themselves, wouldn't they? But, you know,
that's the difficulty.
The difficulty is pulling in work.
Yeah.
You got to know people. Yeah.
Well, just before you were making the list, you were saying about different industries that you worked in and some advice you would give to undergrads. So we talked about, what did we talk about? We talked about consulting and construction. Maybe you could talk about mining as well. How was it like working there?
It's okay. So I work in mining from a consultant's perspective. Sure, I'm not on site. Like I go to a mine site probably once or twice or maybe 3 times a year, depending on the project. And I just go look at things and check things out, and then that would predate the commencement of a design. So a miner would come to us and say, we need this or we want this. It might be a new pump or a new tank to set up a new process stream to do this, or it might be a replacement or something. So we've actually got to go there, physically look at it, and then go back home and then do the design. So I'd figure out basically the process design criteria, which might be, okay, how fast are they pumping this fluid from here to here? What's the total tonnes per, say, day that they're processing, and then go figure out, okay, how fast the pump needs to run, how big the pipeline is in terms of the size of the pipe, where it's going to go, designing your tank, and things like that. So that, in respect to like being on site as an engineer, like in terms of the mining industry, if you wanted to work for a miner directly, your day-to-day would probably look a little bit more like working a lot more with the operations team. So you would set up projects, so you would figure out, okay, what's the bottlenecks in the process at the moment, what are you having trouble with? And they'd probably say, I'll maybe take a different angle on this. A miner would probably say, okay, we process, say, X amount of tonnes per day, or say 150 million tonnes of gold a year, and we want to debottleneck this section of our process stream so that we can, because that's not keeping up with the rest of the plant. So we need to make that faster. We need to figure out how to put more throughput through that, so we can get from 150 million tonnes a year to 200 million tonnes a year. So they would go set up a study and then engage a consultant to go, okay, what are some ideas that you got to sort of make that better? And this would be like the first concept phase would be like, we could do this or we could do that, and then we put together a cost estimate, and then as a consultant we'd figure out, okay, yeah, it might cost you that much. Super high, like easy money, super high level stuff, and then it would go. Then they would say, okay, yeah, we like that. We might put some more money into that study and then take that to a little bit further. And then it'd get a little bit more detailed. You end up doing a little bit more calculations. You'd have more engagement with vendors in terms of like valving, pumps, things like that. You start to get people on board, and then creates a little bit of interest around the project. Everybody sort of get a little bit of hype, Then all of a sudden they go, okay, we want full detailed design. So that's when you get down to like the dimension or the into the details of like how long does a bolt need to be.
Sure.
On each flange, like how big does your gasket need to be between each connection? Like it's to that nth degree, and like it takes a long time depending on the size of the project. But like I've done detailed designs that have taken over a year.
Yeah, wow.
And then as a miner, you get your design, and then you got to go get someone to go build it. So
yeah, And so from what you're telling me, and from what I'm hearing, it sounds like a lot of the technical engineering is done by consultants.
Yes. Yeah.
Yeah. Okay.
Yeah. The reason is because of like mostly to do with like if something goes wrong, like it's mostly to do with insurance. Like.
Oh really?
Yeah. So as a consultant, our business is covered by like insurance. Like as a miner, you don't do your design in house because you don't get that. They're not buying insurances. They're not setting up in-house design teams. If something goes wrong, they want to be able to point the finger. Like nothing usually goes wrong or anything, but like they're not set up focused for design. Like they're set up for processing minerals and selling them. So.
Okay, it's very interesting. And so that covers everything. That's all the industry do. Yeah. Is there anything that you've got a lot of experience now, something that you're maybe looking into, something that's interested in an industry that you maybe don't have much experience in? Or do you think you want to stick with this for now?
I'm not really I haven't really thought much further than where I am at the moment, to be honest. I'm pretty happy with what I'm doing. It's pretty fulfilling. Every job has its ups and downs. I've worked in a few different industries and sectors, and they all have good days and bad days. Some tasks are monotonous and boring sometimes. Some tasks are awesome. So it's like everything really. So I'm not really thought about, I want to go do this or do that at the moment, but we'll see what the future holds.
And even coming to this point where you're at now, did you ever sit down and make a plan, like a career plan about it at all? Or is just the opportunity comes, you take it and...
Like I said, I got into engineering by accident.
Yeah.
I think I got into the construction industry by accident. I'm pretty sure I got into mining by accident.
That's an interesting journey of accidents and you're very open.
That's so interesting. Yeah, every engineer I talk to has a different story like this and a different career path. It's not, you look at becoming a doctor or becoming a lawyer, becoming a nurse. It's kind of staged. The experience
is very much like a clear path.
Yeah.
If you want to become a lawyer, if you want to become a doctor or anything like that, it's a path. You go through these paths A, B, C, D, and then that's the result that you're gonna get. But don't think it's gonna be that easy in the coming years to do it either, because all the disruption is happening.
Yeah, everything's changed. But it's the interesting thing about engineering that I found, just starting my career, it's like you're not being told what levels to go up in because there's so many different opportunities for you and there's so many different paths you can pick.
Yeah. I know so many engineers that don't even do engineering anymore. They're just if you go down that management stream, you're not touching anything technical. It's all about people skills, money, time, schedule, all that stuff. So,
it kind of takes you away from that.
Yeah.
And you're taking the project management side as well, because it's people and project management. Yeah, wow, interesting. Personally for myself, I've enjoyed the technical side. I do like the challenge of it, but I've always enjoyed leading a team a lot more. I found a lot of satisfaction in setting up a place where people can kind of work together really, really well and get the team to produce an output that they wouldn't have been able to do individually. And leading that kind of brings me a lot of joy, rather than just me doing the technical work myself. And so for me, my goal's always been to go down to that project management side, but obviously getting that technical experience first really helps myself as well.
For sure.
Yeah.
For sure. It's only going to support that. So, I think the big thing for me is kids need to get an understanding of what's out there for them. And like I said, I had no idea what I was getting into, and I think it's really important that industry paints a better picture for people to understand the day-to-day a little bit better. Maybe it's career expos, or maybe it's putting industry mentors from industry into schools and universities, and bridging that gap a little bit better. But it needs to be done better, and
absolutely. When I talk to young people in schools, a lot of times it's, I show them a controller board or something, and they see how complicated it looks, and they'll automatically say, I'm not smart enough to do this, I can't touch it. But then if you kind of sit down with them and explain how it works, it's actually not that hard. I think with engineering, and you talk about working with things that are weigh tons, and having this much load and this much impact and safety precautions and things like that. Even as an engineer myself, I look at the things you were describing on the site, and I'm like, I would be a bit hesitant doing that. I probably am not smart enough, or I'm not, capable enough. But
look, it's amazing how much knowledge you actually accumulate over time. A great example was actually today. We've got experts in overseas that are doing a design for us, and I'm sort of contributing where I can, and they're doing the design. I've got to say, sometimes I got to say to myself, look, they're experts, they're more than capable, but I've just regurgitated an Australian standard that I read 3 years ago, and say, oh no, just look at that, and that'll tell you how to do it. Like, you know, it's
Not until you.
yeah. But you know, there's times when you have to.
Sure, you're like that doesn't tell you what to do.
It's not my role, but yeah, you know, but like it's amazing. Like, and I love passing on knowledge to grads. I've not had the opportunity to do it as much in recent times, but I like it's reaffirming of your knowledge and what you've actually learned.
Exactly. Yeah. I was just going to say as well one more thing. So I keep thinking, because I'm just out of uni, so I'm like, hey, these are all the things I didn't know. You touched quite a lot on Australian standards. My girlfriend's doing architecture at the moment, so she touches a lot on Australian standards. So surprisingly, when I was doing engineering, there was like one course that talked a little bit about it. Obviously, coming to industry, you hear it all the time. Could you maybe say what Australian standards is and how you use it in day-to-day?
It's like I said, as a consultant, like when you're doing a design, more so like it's applicable to a lot of different sectors. So like manufacturing. How can I paint a good picture here? If I've done a design for a steel structure, right, there's an Australian standard that says, okay, you've got to design to this set of criteria. There's a Australian standard for a structure, for example, that says, okay, and it paints a map of Australia that says, okay, this area has a earthquake factor of this, and that might be Queensland, or like rural Queensland, and it has a wind factor of this. If it's near the beach, it's more windy. If it's more inland, it's less windy. And you've got to design to these factors. So you design your steel to these factors, and then there'd be that'd be your design standard. Then there'll be a standard for manufacturing. So if you want to make your steel, it's got to be to this grade. You've got to do all this testing to make sure it's good. Like as in up to standard in the sense that like there's no hairline fractures or shearing in the steel, or it's painted to or galvanized to this sort of like thickness, etc. Depending on the application. So blah blah blah. That governs manufacturing, and then there's a standard that governs like how you erect the steel. This is what you've got to do to inspect it as it goes up and make sure it's not not going to fall on anybody.
Yeah.
I think it's more onerous for consultants, from my experience.
And how do you access it? Like,
you got to buy like a license and go through the website called SAR Global. There's thousands of standards out there. Like, I don't know.
Who designs these?
Which are quite expensive.
Yeah, it's expensive. So,
and do you think these standards need to be free for Australians? I mean, the government needs to pay this and make it free for people.
That's a political question. It's tough because
it's not political.
Someone's got to pay it. Someone's got to write them. Someone's got to update them, manage them, keep them up to date. So the guys that do write them, like they put a lot of time and money into it, so they got to get paid. But
no doubt about it. But considering that we are running, we need to run the infrastructure of the country.
Yeah, certainly get where you're coming from. Yeah.
And we need to do all this stuff. Do you think the government should pay it so it becomes free?
Wait, so Australian standards is not a government?
No, it's not free.
It's not free.
But ultimately, we as the people end up paying for that though.
Well, I mean, we eventually somehow is paying it.
Yeah, it's taxpayer money.
It's somehow it's taxpayer money, but at the moment, I'm coming from a point that even for big consultancies, it's a huge cost to pay for the license. And I've heard somewhere that's becoming yearly license, so you can't.
Yeah, I've no idea.
I have no idea either. So at the moment, it's just a little bit way, especially if you work in construction, for instance, for smaller construction companies. It's a huge cost to actually.
So it's almost like a gatekeeping you're thinking, because it's like it's hard to.
I don't think. I don't think there is a monopoly or something. Someone, as George was saying, someone is putting the time and effort to actually provide this information, and all the insurance industry is running off
based on that.
Sure. So you can't really disrupt it because there is a system going on. But then it automatically became a gate that if you want to design something, you're going to go through this hefty process, okay, which no one really benefits from it. And we're already paying this because at the end of the day, the consultants are charging for the major projects all that cost out of the government's pockets. So the government is really paying for it. So why not just paying it up front and make it free? So people who are working in that industry, and especially it's just really fast paced. A lot of things that want to be designing fast. Or the new technologies, new things coming around, especially around, for instance, steel and concrete. Their standards are not catching up. So that's why I'm asking. So, where do you stand on that?
Oh, it's without understanding. Like, I don't fully understand the cost. I don't know what my organisation pays for a license every year. In terms of a dollar value, I'm completely ignorant on that. So it's hard for me to take it. I feel like it's probably I feel like it's probably better for, especially large corporate. Like it's different for a large corporation rather than a small business, because it's a bigger cost for a small business than it would be for a large corporation. But I see both sides to your point. Like it probably does get paid for by the government in some way or another. Like we've got, as a company, when we charge, like our time is money, so our charge out rates is what we get paid in our services. So overheads is built into that. So ultimately, if we work with the government, then it gets paid for by the government anyway in some way or another. So
I wonder if they're making a standard for AI as well, like an Australian standard for that, because it's a brand new technology in the sector. But
could probably Jamie pull that up.
I was actually reading something that with all AI coming out, so AI is finding gaps in industrial standards or any type of standards, because as you were talking before, like AI go and look at them, like because the data is not clear or there is a confusion in the standard, the AI is like, I can't give you an answer because I don't understand it either. So, and that's why if you have an AI now sitting on top of all of these, why not making it accessible for everyone, so everyone can actually contribute to it? Because you as a consultant working on a project and you find a gap in the standard, like I want to add to this because I think that needs to be improved, and some other consultants working on other part of the standards, and I need to, so no, that doesn't work because of X, Y, and Z.
That comes back to my argument. One of the points I made before, because that actually has happened to me. 2 months ago, I was looking at a standard for basically gas, gas connections, gas plumbing, all that type of stuff. There's a couple of Australian standards for gas fittings, connections, design, all that, and it doesn't cover heavy industry. So there's a big gap in that, and then, but as an engineer, you going through the ranks at uni, learning your problem solving skills, you've got to be able to have the ability to put together a sensible design that sort of covers off like energy safety requirements, all your engineering practices, like good engineering practices. You should be able to figure something out. So my worry is without students coming through uni now, I don't know if this is actually happening or not, but heavily relying on AI to get through university, not developing problem solving skills. Like, how are you going to overcome situations like that
when the data doesn't exist?
When the governance doesn't exist. You're going to be able to use your own engineering practices, lean on your own experience, or just get AI to write it for you.
You make a really good point, because university degrees based off of existing knowledge and off of case studies and this kind of thing. It's not based off of leading edge technologies or innovation until you get to your honors rate, then and so that's what AI is good at. We like to say here that data is the bloodline of AI, because it doesn't matter how good your AI model is, if there's no data that it's trained on, it doesn't matter, right? Because it's trying to replicate existing data. And so, like you said, when you're at uni, all these students are studying off AI because there's so much data. It's like there's so much data on thermodynamics that I can ask AI anything I want about thermodynamics and it's fine.
Yeah, the textbook's loaded into it. It's like
Exactly.
talking to a human.
Yeah, but then you go out to industry. Oh, I'm the first company to ever design this. I ask an AI goes, sorry, it's never been done before, I have no idea what you're talking about. And it's like, what do I do now?
Yeah.
Yeah. No, it's gonna be really interesting. It's interesting because like AI is almost like going to replace like the table of contents kind of section. If that, you know what I mean? Because like the table of contents kind of what you use to get to a reference somewhere else in the bigger piece of data or a textbook or whatever you're talking about. But imagine if instead of a table of contents, you just have a chatbot. And you're like, this is what I'm doing, and you can just use natural language, and it goes, yeah, I understand, go look at this, read further about it here.
That's probably what I would encourage young engineers to only let AI take over the table of contents. Don't let it get to your roots.
Yeah.
Because that's why we have jobs. If we didn't have to solve problems, then we wouldn't have a job.
Yeah, exactly. And the one thing you have to give credit for to my high school teachers is that whenever I ask, what does an engineer do? What's the go-to answer? It's solve problems. And if we can't solve problems anymore, then we can't really call ourselves engineers.
That's right.
Yeah. Anyway, I think we might actually wrap up soon. I just wanted to first of all say a huge thanks for coming and being on this podcast for the first time. I'm going to say that because I'm sure we'll have you on again later down the track.
Yeah, happy to come back.
We're having a great chat. And it's a different perspective. We're all kind of in the same industry, so when we talk, we kind of get bogged down in our specific technical side of things, and it's good to have a separate opinion and perspective on things. So, and you're really well spoken as well, so I'm sure everyone's going to have a great time listening to you. So yeah, I just want to say a huge thanks. You're doing a great job, obviously. And yeah, thank you for sharing your wisdom.
No worries. Thank
you very much.
Yeah.
Had a good time.
Thank you.